Okay, welcome to the third lecture of this exceptional week here in Villa Maria Physics. As you know, I hope, we've been working on unit conversions in the last lecture and I guess part of the one before that. That's a really important subject in really any science, particularly the physical sciences, where there are a lot of measurements being done and where you might have to convert from one unit to another in order to actually use the measurements that you've obtained. And so I wanted to start this lecture with some additional practice. I've shown you at least once all of the various types of unit conversions that we're likely to encounter in class, I think. And what I wanted to do now is sort of get some extra practice, sort of throwing types of problems at you more or less at random, because that's basically the way that you probably encounter them in the real world, not all clumped together with the same type. So what I was hoping that students would do in this lecture is follow along with me as I set up each question. When I finish setting up the question, pause the video, try working it out yourself, and then continue the video and compare results. That's the way I usually do in person in class when we're meeting in person. I'll set up a problem and then give the students a few minutes to work on it, and then we'll compare results. Here on the video, it doesn't really make sense for me to just sit there with dead air for several minutes after I set up the problem. So I'm going to go right on to the solution. And so it's basically going to be up to you to pause the video while you work on the problem, and then we can compare results. Please do that, though, because it is by far the best way to learn how to do problems like this is by practicing them yourself, even if it involves making mistakes, because then you learn what not to do, and that's almost as important as what you should do. It works, I know from experience, it works much better than simply sitting there and watching somebody else do it. So you definitely should participate on your own in this. Because of that, this third lecture might be a little shorter than the other ones, because I'm assuming that you're going to be pausing the video and working the problems. But oh well, I'm sure you won't be too disappointed if that happens. Okay, so I just have a bunch of fairly random unit conversion problems here. Okay, so convert 6 milliliters to gallons. In doing any kind of unit conversion, the first thing you probably want to do is ask yourself, what kind of measurement is this? Is this a length or distance, or is it a mass, or is it a volume, or is it a speed, or what? Well, in this case, obviously, milliliters and gallons are units of volume. Then you can go to your handy conversion factor chart and see what kind of conversion factors you can find for volume. Here we've got liters to quarts, cubic inches, gallons to liters. What was this again? Oh yeah, okay. We've got gallons to liters. Actually, if we can get from milliliters to liters, then we can get the gallons. So actually, getting from milliliters to liters is pretty simple, since that's within the metric system. And so we'll do that. So we'll use that one. Okay, so we know this. So if we can get from milliliters to liters, then we can get the gallons. And we know that 1 milliliter equals, 0.001 liters, 1/1000th of a liter. Or 1 liter is equal to 1,000 milliliters. You can do it. You could use either one of these, because in the equation, they will work out the same way. So if we have 6.0 milliliters, And again, we can consider that to be the numerator. And now we want to go to liters. We want milliliters on the bottom to cancel out, and we want liters on the top, so that we'll end up with that as the unit, the new unit at this point. And it's 0.001 liters for every 1 milliliter. Note that milliliters will cancel, and we now have liters as the unit. And now if we look at the other conversion factor, we need to go to gallons. That means liters needs to be on the bottom, so it will cancel, and gallons can be on top. 1 gallon for every 3.786 liters. Liters cancel, and if we multiply this out, we will have 6 times 0.001 divided by 3.786. Again, you could ignore the ones because they don't change anything. That makes things a lot easier. Right about 3.786. And that gives us 0.001584786 gallons. One thing you might notice, hopefully, and this is a good thing to be thinking about, is that milliliters are a pretty small unit of volume. Because remember, 1 milliliter is the same as 1 cubic centimeter. 1 cubic centimeter is about the size of a sugar cube. Okay, so that's a pretty small unit of volume. Gallons, on the other hand, are pretty big. So if the unit gets bigger, the number should get smaller. And it did, so that's a good sign. Now we need to think about significant figures, because clearly, this is what the calculator gave me. Clearly, that's too many. 6.0 has 3. 0.001, well, actually 0.001 and the 1, that is a conversion within the metric system, so that's infinite. Gallons to liters, though, that is between the English and metric systems, so that's not infinite. That's going to be 4 significant figures. So it looks like 3 it is. That means the 1 and the 5 and the 8 are significant. Remember, zeros at the beginning of a number don't count as significant. Before writing the 8, though, I'm going to check the first number we're dropping, which is the 4. Since 4 is less than 5, we don't have to round the last number we're keeping up. We can leave it as an 8. And so we get 0.00158 gallons. That's the decimal form of the number. We can put it in scientific notation too. Really, I would recommend, if you're doing it on a test or a quiz, don't change from, well, let's say if numbers are extremely large or extremely small, then you should put them in scientific notation. You know, like Avogadro's number, like I showed in class, 6.02 times 10 to the 23rd. There is no reasonable way to write that in the decimal form. That should, numbers like that should absolutely be in scientific notation. Number like this, it's pretty reasonable to write it either way. And I would recommend leaving it in whichever way you calculate it, because changing it, unless I specify that this answer needs to be in scientific notation, then you should leave it the way you got it. Because changing it, you might make a mistake. Now you lose some points where you wouldn't have if you'd left it alone. Now remember, we need a power of 10 here. So in order to get the 1.58 to be, in order to get this number between 1 and 10, we had to move the decimal point until the number was 1.58. That's between 1 and 10. In moving it, we moved it 1, 2, 3 spaces in the direction that made the number bigger. So the exponent has to be smaller, in other words, negative. So it's 1.58 times 10 to the minus 3 gallons. That would be the other way to write it. And as just a demonstration of, I've mentioned before that most conversions can be done in practically an infinite number of ways. And I thought I would just show you another way to do it. We noticed, if you'll notice here, we had, a conversion between liters and quarts. So that we could use that too. Because 1 liter is 1.057 quarts. One gallon is 4 quarts. Again, that's why they call it a quart, because it's a quarter gallon. And we can easily go from liters to milliliters. So, milliliters to liters to quarts to gallons. That's the way we're going to be going here. So you're kind of looking on the conversion factor chart. You're looking either for one of the quantities that you have in the conversion problem, in this case milliliters or gallons, or something that you can hopefully easily relate to one of those units. Okay, so we had liters and quarts. The problem gave us milliliters and asked for gallons. But I know that if I have liters, I can get from milliliters to liters pretty easily. And if I have quarts, I can get from quarts to gallon. So that's the intermediate stage there, liters to quarts. We have 6.0 milliliters. And if we want to go from milliliters to liters, that's the same as the first step we did just now. Milliliters will cancel, and now we have liters. To go to quarts, what we need is this first conversion factor here. Liters will need to go on the bottom, and quarts on top. Liters cancel, and we now have quarts as the answer, as the unit for our answer. Now we can go to gallons. Now that we have quarts, quarts as a unit needs to go on the bottom along with its associated number, and gallons can go on the top. Now quarts cancel, and we have gallons as the unit. So 6 times 0.001 times 1.057 divided by 4 equals 0.0015855 gallons. And this may not look so similar to what we had before. Not exactly the same, because some of the numbers were rounded off slightly differently than they were before. But if you look at the significant figures, once again, we're going to be limited to 2. Oh, did I say 2? Shoot. 6.0 is 2 significant figures. What am I thinking? Okay, that means this is 0.16. Sorry about that. Or 1.6 times 10 to the minus 3. All right, 2 significant figures. The metric conversion is infinite. The metric English conversion is rounded. Once again, though, that's 4 significant figures. And the conversion within the English system is also infinite. So 2 it is. And if you round this off to 2 significant figures, you notice the zeros at the beginning don't count. You get 1, 5, those can stay, but everything from the 8 on has to go. The 8 is greater than 5, and so the last number you're keeping has to go up by 1. So it's 0.0016 gallons. To the correct number of significant figures, it is exactly the same as what we got up above. The other numbers that were different beyond that, those are numbers that we didn't really know anyway. They were numbers that we got because the calculator assumed things that we don't really know. It assumed that we knew the numbers more exactly than we really do. Okay, so either way you get the same answer. Either way is correct. There are other ways to do it too, but I think 2 is enough for us right now. Let's see. I'm looking for a good one here. How about 150 kilometers per hour to meters per second? That's actually not very difficult. This is a speed. And if you're using the conversion factor sheet that I gave out at the beginning of the semester, you'll notice that there is an entire section devoted to conversions for speed. And if you're using this section, the conversions for speed, then you can write the, the speeds as I wrote them here, as km/hour or meter/second. If you're going to try to convert kilometers to meters and then hours to seconds separately, then you would want to write it as 150 km over hours explicitly. But if you got this sheet, you might as well use it. So we're going from kilometers per hour to meters per second. I have a feeling we're going to be able to do this in one step because there's kilometers per hour right there, and there's its equivalent in meters per second. Very first thing. So there's our conversion factor. So if we have, okay, we have 150 kilometers per hour. Since we're using the speed conversion, we can consider kilometers per hour to be entirely in the numerator. And our conversion factor is going to have kilometers per hour in the denominator and meters per second in the numerator. So now kilometers per hour will cancel out, and we get 150 times 0.2778. And we get 41.67 meters per second. Now this is a case where you have to be careful because 41.67 is a pretty reasonable number of significant figures, or it appears to be anyway. So you have to be sure to go back and check anyway, even if you don't get a huge number of significant figures out of the calculator as an answer. For 150, you'll notice that there's no decimal point. So that's only two significant figures. Meters per second to kilometers per hour is a metric English conversion, so that is rounded off. And 0.2778 is obviously four significant figures. So 2 is all we're allowed in the answer. So we get to keep the 4 and the 1. Everything from the 6 on has to go. 6 is greater than 5. So the last number we're keeping has to go up by 1. In other words, 41.67 rounds off to 42. And that would be the correct answer to the correct number of significant figures. Okay. If we had something like if you were to convert 18 cubic inches to, say, cubic kilometers, how could we do that? Okay, so again, I haven't been saying it, but this is where you'd pause the video and try doing it yourself. And then when you come back, we'll compare notes. Okay, so if you're back now, we've got cubic inches to cubic kilometers. These are units of length. So you'd be looking for conversion factors. Well, actually, sorry, let me correct that. Length units to the third power are units of volume. So you can try looking under volume, but I have a feeling you're not going to be able to find anything useful under volume. Oh, maybe you will. Let's see. Oh, we have cubic inches to cubic centimeters, actually. If you can get to cubic centimeters, that's a metric unit, and getting to cubic meters from there should be fairly easy. So actually, we could use that one. So volume it is. Okay. And what was it again? 1 cubic inch is 16.39 cubic centimeters. Okay. So we start with 18 cubic inches, and you can consider that the numerator. And we next want to go to cubic centimeters. Cubic centimeters will go on top, and cubic inches go on the bottom. This conversion factor, remember though, you got to be careful here. This conversion factor is already cubed. So the 3's go inside the parentheses, and you don't have to cube the numbers because they have already been cubed. You know, the conversion factor in linear measurements, 1 inch is 2.54 centimeters. Well, we get to the conversion factor 1 cubic inch is 16.39 centimeters just by cubing both sides of this equation. 1 times 1 times 1 is 1, so it's 1 cubic inch. 2.54 times 2.54 times 2.54 happens to be 16.39. So that's what I mean when I say the numbers have already been cubed, so don't cube them. Okay, so cubic inches cancel with cubic inches, and we would have cubic centimeters as the unit, at this point. Now, you'll notice that the volume chart doesn't give a conversion between cubic centimeters and cubic kilometers. For that, you pretty much have to rely on the linear conversions of length units to the 3rd power. And for that, we just use the metric prefixes. So first, we want to use the conversion between the linear length units, that is the one-dimensional length units, that is length units to the 1st power, for centimeters to meters. Because if we want to go, if we're in centimeters now, if we want to go to kilometers, these are 2 units, two metric units, both with prefixes. It makes sense to stop off at the base unit first. In other words, go from cubic centimeters to cubic meters, and then from cubic meters to cubic kilometers. Okay, so for the one-dimensional units, we know that there's 0.01 meters for every 1 centimeter. But these are one-dimensional units, and these are 3-dimensional units. And so the way to get this conversion factor to work out so the units cancel is to cube the entire conversion factor. Because these dimensions inside this conversion factor have not been cubed yet. So the 3 goes on the outside of the parentheses, and you have to remember that everything inside the parentheses still needs to be cubed. And that's why I drew that little arrow there, just so when I'm multiplying through, I won't forget that that 0.01 has not been cubed yet, although the 16.39 has been cubed. So this will be cubic centimeters on the bottom versus cubic centimeters on the top. They will cancel out. And we have cubic meters as the unit at this point. And we can go easily to cubic kilometers, just again by using the metric prefix. Kilo means 1,000 of something. So 1 kilometer is 1,000 meters. We want meters on the bottom, of course, so that it will cancel out with meters here. And of course, since these are cubic meters, these need to be cubic meters, but those need to be cubic kilometers, and the numbers need to be cubed also. So again, we write the 3 outside the parentheses so that it applies to everything inside the parentheses. So now this is cubic meters here on the bottom, and it can cancel with cubic meters there on the top. Now we have cubic kilometers for the unit, and that should be okay. On the calculator, let's see if I can get in an angle where you can actually see it. I would take 18, oh, not pi 8, 18 times 16.39, okay, times, no, you can't see it, can you? Parentheses 0.01 raised to the third power, close parentheses. And then I hit equal just to avoid any misunderstandings. And then I take that times, or sorry, note divided by 1,000 to the third power. Okay, and then close the parentheses and hit equals, and we get this number, 2.9502 times 10 to the minus 13. Oops. Okay, that 10 to the minus 13, first of all, it's a very small number, but cubic kilometers is a pretty large unit of volume. So, and cubic inches is a pretty small unit of volume. It's like the side of a child's wooden playing blocks, you know, that's about a cubic inch. So we go from that to cubic kilometers, we would expect the number to get smaller because the unit got bigger. And boy, did it ever get smaller. And now we have to also think about significant figures. 18 is only 2 significant figures. 16.39 is 4. Metric conversions are infinite, so that one is also infinite. 2 it is. That means the 2 and the 9 can stay. But the first number we're dropping is a 5. That means the number before it has to go up by 1, but that has a knock-on effect of raising the number before that. So 2.95, blah, 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 actually rounds off to 3.0 into 2 significant figures. So 3.0 times 10 to the minus 13 cubic kilometers. Okay, well, that takes us up to the end of the first section of this lecture. So I'll be back in a moment with the second.